Quadratic application number 5. This is going to be a little bit different than what we've done before, but you're still using quadratics to solve a real world problem. So, Mrs. Pond has 30 yards of fencing, and she wishes to use it to enclose a rectangular garden. If all the fencing is used, what is the maximum area the garden could be enclosed? Now, this is something that you really can use in real life, and it helps you find the max area that you can use, and you're actually going to be kind of making your own equation. So first of all, let's draw the picture, and the picture is of a rectangular garden. So let's draw it, and draw it kind of large. So here's my rectangular garden. Now we know, because it's a rectangular garden, that this side is equal to this side, and this side is equal to this side. So I'm just using X's and Y's. You could use L's and W's, it doesn't matter. I'm just picking X's and Y's. Now, in order to solve this problem using algebra, first thing is you're going to have an equation called a constraint. And then you're going to have your objective. This is what you want. Okay, so the constraint is what they give you. So in this case, they gave us that it's 30 yards of fencing. That means the constraint means that holds you back. You have to have 30 yards. The objective is what you want, and I want max area because I only have 30 yards of fencing. Okay? So you're basically going to come up with your constraint equation. Now, if I'm doing 30 yards of fencing, when I fence it, I'm going to be fencing it all the way around. And we call that perimeter. Because I'm doing this all the way around, I'm going to do this fence. So if I were going to do a formula for perimeter, or fencing if you will, we could call that P or F, you'll notice that I'm going to go all the way around. So I'm going to say, well, that's 2x's plus 2y's. I just came up with a constraint equation. Now they told us I had to use 30 all the way around, so I know my perimeter has to be 30 of fencing. So it's 30 equals 2x plus 2y. Now my objective is I need to find the max area. So the area here is going to be x times y, or y times x, because that's area is base times height. But according to our picture, that's what we're going to call it. Now, in order to find this objective, or what we want, this is what we need. Okay? We have to basically make sure the constraint's in there. So I'm going to take this, solve it for a variable. Now I'll solve for y just because we're used to doing that. So if I subtract 2x on one side, I have 30 minus 2x equals 2y. And if I divide through by 2, I have y equals 15 minus x. You're going to take that and actually plug it into that y spot, because you have to put your constraint in there so you can find the maximum area with 30 yards of fencing. So I have a equals x times 15 minus x. Now when I do the distributive property, I have 15x minus x squared. And guess what I have? I have a parabola. There's my 2. It's negative. This is my a and this is my b. See how it's backwards? There's my a. And I look at it and say, oh, wait a minute. This makes sense because it wants maximum area. So it's got to be a parabola that opens downwards and has maximum problems. So Mrs. Pond said anytime we do maximum area, we have to use the axis of symmetry. So I'm going to find the axis of symmetry. It's negative b over 2a. Because this will tell us the x that will give us the maximum a. So this is my a, my b is 15, so it's going to be negative 15 over 2 times negative 1, because that's my a. So it comes out to be 7.5, and we're talking yards. So now if I come over this picture, I know this is 7.5 wide and this is 7.5 wide. Now how do I find the y? Well, you take 15 minus 7.5, and if I did, that would be 7.5 for my y's. Now, you might say, wait a minute, that's not a rectangle, that's a square. Well, a square is a rectangle, and the maximum area, you'll notice, is either a circle or as close to a square as you can get. So there it is, what I need for fencing. I go 7.5, 7.5, okay? Then I go look up here. Have I answered the question? No, they want to know what is the maximum area I can use. Well, I know the dimensions, so I'm actually going to put it in the area formula. It's going to be 7.5 times 7.5. And when I multiply that out, I get the area to be 56.25 square feet. Now you're done.